classroom video for Further Maths Unit 2, Mean and Variance of a Combination of Independent Random Variables. Remember that for various distributions we have the evaluation of mean and variance of a random variable to be in descriptive statistics, and for discrete distributions we have the mean given as x bar being the sum of all the x's divided by n, and the variance is defined to be the difference from each term of the mean, square that to get rid of the negatives, and divide by n. But if we multiply the square bracket out and take the sigma in, x bar is a constant, so we can take the sigma in, so we go sum of x squared minus 2x bar sum of x minus n sum of x bar squared. Being as we're adding n times, we need n of that constant, all divided by n. Now if we substitute for each x bar x sum of x over n and sum of x over n, then we have here twice minus twice sigma x all squared divided by n, and one of these n's will cancel, so we've got plus a sigma x squared over n here, giving us an alternative form of the variance, which is more practical to use. So we have minus 1 of the sigma x squared over n. 1 over n, sum of sigma x squared minus sigma x all squared over n for the variance. Another way of working that out, if we take the n in to the bracket, we have the variance, the mean of x squared, so x squared, sum of x squared divided by n is the mean of x squared, and then the mean of x all squared there, so minus that, and instead of writing the mean of x squared, we can write the expected value of x squared is also the mean, so expected value of x squared minus the expected value of x all squared instead of the variance. So another way of working out the variance. For frequency distributions, so for distributions linked with frequency, we just add an f. When we're adding up all the x's, we need to multiply each by how many we've got, and then divide by the total of the frequency, i.e. divide by n. And the same for the variance, add an f within the formula for variance. For data linked with random experiments and corresponding probabilities, we have that e of x is the sum of each x multiplied by its probability. If we wanted the expected value, e of x is called the expected value, it's the mean. Expected value of e squared is the sum of all the x's squared multiplied by its probability, and then we can work out the variance, which is e of x squared now minus e of x all squared. If we've got tables with linked probabilities. And then of course the standard deviation is the square root of the variance. Now some you've come across before, the binomial distribution with parameters n and p. The expected value, the mean, is n times p, and the variance is n times p times q, where q is 1 minus p, not x. Probability of not x. A Poisson distribution has got parameter lambda, and its mean and its variance has the value lambda. For two or more random variables, let x and y denote two discrete random variables, then the joint distribution of x and y will be the probability of x equals each xi and y equals each yi for every xi and yj with the corresponding probability p, I and j, representing the probability of the joint x and y. And note that the sum of all the pi's, i's, j's will equal to 1. All the probability will add up to 1 for the joint probability. Then each x equal to xi must occur with any one of the y's in the distribution of x, is therefore the probability of x is equal to xi with the probability of each I with the corresponding j1, 2 and so on up to s for the j and up to r for the I. Similarly, the distribution of y would be the probability of y equals each yj for each j and I being 1, 2, 3, 4 up to r and j 1, 2, 3 up to s. So we have those probabilities for the x and the y, and then the expected value is defined to be, so the expected value is the sum of the function of x and y with the corresponding probability, the sum for both the I and the j. For this function of x and y, i.e. ax plus by, the expected value is the sum for the I and j of a times the x term and b times the y term with the corresponding probability. We can take the sigma in to each x and its probability and y and its probability. So we've got a times the sum of the xi and the sum of the p with the ij, and then b with the sum of the y's for j1 to s, and then the probability for the I, the probability ij for each I. Then we've got there the probability of x is xi for the sum of the p's, and the sum of the pij for the I is the respective probability of y equals yj. So we've got now that the expected value of a times x plus b times y, expected value of all that is the a times expected value of x, which is that bit, plus b times the expected value of y, which is that bit. So that's the formula you need to remember. For independent a and b, we have that if we want the probability of a and b occurring, being if as they're independent, we can multiply them. Therefore, we can use the expected value of x times y to be the expected value of x times the expected value of y, only if x and y are independent. Therefore, the variance now then, that's what we need to work out, of the combination of ax plus by is the expected value of the combination squared minus the expected value of the combination all squared. Multiplying these out, and we have, so we've taken the e in there before squaring the bracket before taking the e in, then take the expectation in here and squaring that bracket, and we have the term e of x times y, which we know now, being as they're independent, is equal to ex times ey. Therefore that term there is going to cancel. We can do that being as they're independent, and we are left with a squared e of x squared minus a squared, taking the a squared out, e of x all squared, plus b squared e of y squared minus the b squared, take it out, e of y squared, so giving us a squared times the variance of x plus b squared times the variance of y. That's the variance of y, that's the variance of x. So we have the expectation of ax plus by is a times expected value of x plus b times expected value of y, but the variance is a squared now times the variance of x plus b squared times the variance of y. And to work out the standard deviation, we would just take the square root of the answer. Therefore, we have these formulas which you need to learn. If we only have one variable, no y, and we have a linear combination of x, as in ax plus b, then the expectation of that, take the expectation in, and the expected value of b is just b. So the expected value of ax plus b would be a times the expected value of x plus b. While the variance, take the variance in, and I've got a squared times the variance of x plus b squared times the variance of 1. When 1 does not vary, therefore that is 0. So we have only a squared times the variance of x for the variance of the combination. So all those formulas we need to remember. Let's have a look at a few examples. The random variable x and y are independent, and u is the combination of 3x minus 2y. The mean and the standard deviation of x and y separately are given in the table. Find the mean and the standard deviation of u. So we have a combination. So the expected value of x is 12 and the variance of x is 4. We can't use standard deviation. We need to go back to variance. And for y, the expected value of 10 and the variance is 16. Therefore, we need the mean of u, which is the expected value of u, which is the expected value of 3x minus 2y. So I can take the expectation in. So it's 3 times expected value of x minus 2 times expected value of y. I can put the values in and I get 16 as the mean of u. The variance of u, so I want the variance of the combination. I take the variance in and I square the coefficients. So I've got 9 times the variance of x plus 4 minus 2 squared is plus 4 times the variance of y. Put the values in. I got 9 times 4 plus 4 times 16 giving me 100. Therefore the standard deviation is the square root of that, which is 10. So plain combination there. It's not binomial or Poisson or any of the other distribution. Just a plain two variables. Right, another question. The independent, again, random variables x and y are Poissonly distributed with means 2 and 3 respectively. Show that the expected value of e of x squared is equal to 6 and evaluate e of y squared, and then reduce the value of e of x squared times y squared, and then work out the standard deviation of u, which is a multiple of x and y. We're given Poisson, we're given they're independent, so x is Poissonly distributed with mean of 2, so its mean and its variance is 2, and y has got a mean of 3, so its mean and its variance is 3. Variance of x is defined to be e of x squared minus e of x all squared. So if I put the values in, I've got 2 equals e of x squared minus 2 squared, which I can rearrange, and I'll get e of x squared is equal to 6. Do the same for the variance of y. So we know the variance of y is 3 and the expected value of y is 3. Rearrange and we get the expected value of y squared is 12. Now, being as x and y are independent, so x squared and y squared are independent of each other, so I can get the expectation of the product of those two. So e of xy is e of x times e of y, which implies that e of x squared times y squared, being as they're independent, is equal to v of x squared times e of y squared, which I can work out to be 72. So that's the value of part 2. The variance of u is given as e of u squared minus e of u all squared. So I can put u squared being xy. So I've worked out e of x squared y squared. It's 72. And I know that e of xy can be multiply each other. So I've got 2 times 3 there. I've got 72 minus 6 squared, which gives me an answer for the variance of being 36. So the standard deviation is the square root of that, which is 6. You need to go through the variances. You need to use the e of x squared, the e of y squared, the e of u squared. One more, a binomial distribution using a formula, a combination. The binomial x has a distribution that's 10, n is 10, and p is 0.4, and y independently, again we need that word in, has the binomial distribution, n is 30, p is 0.3. Show that e of x squared, like the last one, is 18.4. Evaluate e of y squared, and then we've got a multiple of xy. Work out the mean and variance of those. So for x, we have the mean being np now, so which is 4, and the variance is npq, which is n times p times 1 minus p, which is 2.4. Binomially, we're given n and p, so we need to work out the mean and the variance of x and for y separately first. So np for the mean of x of y, and npq for the variance of y. Show that e of x squared is equal to 18.4. So we get e of x squared by rewriting the variance of e of x squared minus e of x all squared, putting in what I know, I can work out that e of x squared is 18.4. Variance of y is e of y squared minus e of y all squared, put in what I know, rearrange, and I get e of y squared being 87.3. So the mean of u, the combination, being as they're independent, I can multiply them, and I get 4 times 9, which is 36. The variance, I need to go and find e of x squared times y squared, and then minus e of xy all squared. So e of x squared times e of y squared, as they're independent, minus, that is 36 from over there. So I can multiply these. I've got 18.4 times 87.3 minus 36 squared, which is 310.32 for the mean and the variance. These are just examples which have come up in past papers. There are a number of examples of these in the past papers. They're also similar to what's given in the sample new syllabus paper, and last year's 2018 paper are similar to these questions. And that's the end of the video on mean and variance of a combination of independent random variables.